Hello everyone, my name is Maxim and I'm from MS9A. Today I will read and translate reading passage 2, a second attempt at domesticating the tomato. Uh, it took at least 3,000 years for humans to learn how to domesticate the wild tomato and cultivate it for food. Now, to separate teams in Brazil and China have done it all over again in less than 3 years. And they have done it better in some ways, as the redomesticated tomatoes as more nutritious than the others we eat at present. This approach relies on the revolutionary Krebs genome editing technique, in which changes are deliberately made to the DNA of living cells, allowing genetic material to be added, removed, and altered. The technique could not only improve existing crops, but could also be used to turn thousands of wild plants into useful and appealing foods. In fact, a third team in the U.S. has already begun to do this with a relative of the tomato called the ground cherry. This fast-track domestication could help make the world's food supply healthier and far more resistant to diseases such as the rust fungus devastating wheat crops. This could transform what we eat, says George Kuda at the University of Munster in Germany, a member of the Brazilian team. There are 50,000 edible plants in the world, but 90% of our energy comes from just 15 crops. We can now mimic the node domestication course of major crops like rice, maize, sorghum, or others, says K.C. Scan of the Chinese Academy of Science in Beijing. Then we might try to domesticate plants that have never been domesticated. Wild tomatoes, which are native to the Andes regions in South America, produce pea-sized fruit. Over many generations, people such as the Aztecs and Incas transformed the plant by selecting and breeding plants with mutations in their genetic structure, which resulted in desirable traits such as larger fruit. But every time a single plant with a mutation is taken from a larger populations for breeding, much genetic diversity is lost. And sometimes the desirable mutations come with less desirable traits. For instance, the tomato strains grown for supermarkets have lost much of their flavor. By comparing the genomes of modern plants to those of their wild relatives, biologists have been working out what genetic changes occurred as plants were domesticated. The teams in Brazil and China have now used this knowledge to reintroduce these changes from scratch, while maintaining or even enhancing the desirable traits of wild strain. Kudla team made 6 changes altogether. freezing. They triple the size of fruit by editing a gen called fruit weight, and increase the number of tomatoes per choice by editing another called multiflora. While the historical domestications of tomatoes reduced the levels of the red pigment lycopene, thought have potential health benefits, the team in Brazil managed to push it instead. The wild tomato has twice as much lycopene as cultivated ones. The newly domesticated one has 5 times as much. They are quite statey, says Kodla, a little bit strong and very aromatic. The team in China domesticated several strains of white tomatoes with desirable traits, lots in domesticated tomatoes. In this way, they managed to create a strain resistant to a common disease called bacterial spot race, which can devastate yields. They also created another strain that is more salt tolerant and has higher levels of vitamin C. Meanwhile, Jobs Van Eyck at the Barnes Thompson's Institute in New York state decided to use the same approach to domesticate the ground cherry, or golden berry, Physos brunosa, for the first time. This fruit looks similar to the closely related Cape Coast gooseberry. Ground cherries are already sold to a limited extent in the US, but they are hard to produce because the plant has a sprawling growth habit and the small fruit fall off the branches when ripe. Veik's team has edited the plant to increase fruit size, make their growth more compact, and to stop fruit dropping. There's potential for this to be a more commercial crop, says Van Eyck, but she's added that tackling the work further would be expensive because of the need to pay for a license, the license for the CRISPR technology, and get regulatory approval. This approach could push the use of many obscure plants, says Jonathan Jones of the Saints Perry lab in the UK. But it will be hard for new food to grow so popular with farmers and consumers that they become near stable crops, he thinks. The three teams already have their eyes on other plants that could be catapulted into the mainstream, including foxtail, artgrass, and cowpea. By choosing wild plants that are drought or heat tolerant, said Scone, we could create a crop that will thrive even as the planted worms. But Kudla didn't want to reveal what species were in his team's signs, because Scripps has made the process so easy. Anyone with the right skills could go to their lab and do this. Thank you for listening.